Okay, they are telling us there is a function f, which is e to the negative x squared. So first thing they want us to do is write the first four non-zero terms and the general term for that series f. So because we're talking about a Maclaurin, it tells us it's centered at 0, and we're talking about a form of e to the x, what I want to do is start with e to the x. I do not want to take the derivatives, right? So I'm going to write the first couple terms here just so I can get the idea. And the general term for this is pretty straightforward. So e to the negative x squared is just going to be replacing negative x squared wherever I see an x. So this becomes negative x squared. I'm going to plug in a negative x squared wherever I see an x. And same thing for the general term. And it is a series, so make sure you write the plus dot dot dot. So this would be your first four non-zero terms and the general term. Okay, part B. Use your answer from part A to find the limit. Okay, so anytime we have a limit problem, step one is let's do a direct substitution. So I have 1 minus x squared, and then we want to subtract off all of f of x. So f of x is what we came up here. So I'm going to just write some of it. I'm going to just clean this up a little bit. So this is really plus x to the 4th over 2 factorial minus x to the 6th over 3 factorial. And it goes on forever, right? We are writing all the terms. I just wrote the first couple. You'll notice that something will happen. So this is what I'm trying to figure out. Now, if you plug in 0 right away, you're going to get 0 over 0, so we can't have that. But let's clean this up a little. You'll notice a lot of things happen. This negative sign, right, has to get distributed everywhere. So the 1s will drop out. The minus x squared and the plus x squared will drop out. So really what you have is this now. This negative, if it gets distributed, you have this. And obviously there's more terms, but I'm just going to write the first couple and you'll see something happens. Notice what happens is you are going to divide every term through by x to the 4th. So for the first term is negative 1 over 2 factorial. Your second term looks like this, and there's more terms that go on, but notice every single term after this has an x there, so when I take the limit as x equal to 0, all you're left with is this term, which is negative 1/2, and that's how you get to that limit. Let's get rid of this. Okay, part C says, write the first four non-zero terms in the Taylor series for this antiderivative. And once we do that, we're going to estimate this definite integral. Okay, so step one is we have to figure out what this is. And it says we want the first four non-zero terms of this. So this is basically integrating. And we're going to use t instead of x. So I'm going to use these terms here. So 1 minus t squared, I'm going to clean this up, plus t to the 4th over 2 factorial minus t to the 6th over 3 factorial. Right? Once we start working with the series, this is when I want to simplify things a little bit just to make it easier. So if I integrate this, I get t minus t cubed over 3 plus t to the 5th over 5 times 2 factorial minus t to the 7th over 7 times 3 factorial. And let's plug in our bounds. So when I plug in x, end up with this. And when I plug in the 0 bound, everything zeroes out. So this is going to be the first four non-zero terms of the integral. And then it says use only the first two terms to estimate the value of the integral from 0 to 1/2. So I'm just going to use these first two terms to integrate to figure out an approximation for this. So this is approximately 1/2 minus, what's it, 1/2 cubed divided by 3. And you could leave your answer like this here. Okay, lastly, part D. Explain why the estimate found in part C differs from the actual value by less than 1 over 200. So we're looking for the difference between the estimate and the actual, so that's your error bound. Notice that in the integral that we, so in part C, we came up with this. this was the antiderivative that we came up with. In our estimation, we only use the first two terms, okay? We want the error bound. Notice that this is an alternating series. So for an alternating series, the error just comes from the next term that we don't use, so this is it. It's just x to the 5th over 10. That's your error. It's the next term that we're not using. And what number are we plugging in for x? The number we plugged in was 1/2. So it's 1/2 to the 5th divided by 10, which is 1 over 320. And you could check for yourself, it is less than 1 over 200.